Okay, now, as we go through this next little chunk of the lesson, you are going to write down and record the learning on the little half sheets of paper that I just handed out to you, so make sure you have one in front of you. Okay? Your name goes at the top. The learning goal is right below it. Okay? And the purpose of this lesson is to really tie together the two standards that you guys have already learned and apply it to the big idea. Okay, what are we trying to get across to you with teaching these two standards? So, Isaac, can you read the learning goal for me out loud, please? Appreciate you.
I can use what I know about atomic structure to explain why the molecules are arranged in certain ways to form the different states of matter.
Okay, so you learned about states of matter. Tell me what they are.
Solid, liquid, and gas.
We know this since 5th grade, right? Solids, liquids, and gases. Okay, maybe 3rd, maybe 5, right? You've known this for a while. Solids, liquids, and gases. Okay, and then we taught you this atomic theory, right, which we talked about matter's made up of atoms. The atoms are then made up of subatomic particles. They have charges, all this stuff. So how do these things connect is what this lesson is going to kind of bring it all together and give you like a picture of it, okay? So part A is the science starter reflection. So if you don't mind real quick, the activity we just did, you're going to process and fill out part A of the science starter reflection, and then we're going to get started on part B in just a minute. Fill out part A. How we doing? So part A, so number 1, what type of atom is this? How do you know that? How would you know? How did you figure out what this is?
Well, you know at the top. How do you know?
Because of what? That number tells you what?
The number of protons.
Perfect. So what could you do here to figure it out?
Count the number.
Ooh, you're on a roll. All right.
I'm confused with like the overall charge. Like, does that mean like basically the atomic mass?
No. So we're talking overall charge. So you have the same number of protons and electrons, correct? And one has a positive charge and one has a negative charge. So if you have 9 positive charges and then 9 negative charges, what's the overall? Yep, there you go.
Oh, but we have 10 negative.
So would it
So,
be neutral or 0?
So how many here do you have?
6.
6. All right. So
Oh, we have 0.
is that fluorine?
oh, I thought you were telling us to process what we
No,
had
this
here.
one right here. Good question. So not the one that you had at your group. In the reflection, it's the little atom over to the side.
Two questions. The net weight, the overall charge be so would it just be the amount of protons? Because
So when we're talking about charge, what pops into your head?
so would it be zero because
Why would it be 0?
6 protons and then 6 neutrons that doesn't add and then 6
Do you know, Ryan?
electrons take away
So you're on the right path. So protons have what type of charge?
positive
Okay. Neutrons have
neutral
no charge, so they're not going to affect anything, right? What's the other particle that has a charge?
electron and they have a negative charge.
They have a negative charge. Okay. So if you have 6 protons with a positive charge and you have 6 electrons with a negative charge, that overall charge is going to be what, Ryan? Do I need to rap it in Amigos song?
Wouldn't they just cancel each other out?
They would. So the number would be,
0.
there we go.
I thought you already said that though.
I wanted you to say it. That's what I wanted. How we doing? Got it?
No.
We're looking up the periodic table right now.
I feel like it's.
Okay, so it has
I was wrong.
It's got 6.
Right here.
fluorine. So it's carbon.
Yay! Did you guys get it back here?
So the overall charge of this atom would be 6.
Okay. When we talk about the word charge, what do you think we're talking about here?
So like positive, negative.
Positive, negative. Okay, good. So what do we know about positive charges? What particle is that? The proton. How many do you have?
6.
Okay. The neutrons have what type of charge?
None.
None. So they're not going to affect Anything. They have no charge. What's the other particle that has a charge?
Negative.
Negative. And how many of those do you have?
6.
So if you have 6 positive and then 6 negative,
It's even, so they're gonna get back at each other.
so
Neutral.
it's neutral, which means that it's
0.
you got it. How we doing, Josh?
So it's a neutral charge. Yeah, right. It's just 0. Like.
Got it.
All right, all right.
You got it. All right. Okay. Yes.
What type of atom is this? Does that mean like?
So based on this picture right here,
Okay.
and you know, look, you already wrote it down.
Oh, that's the type
Yeah.
of atom it is? Oh.
Yeah, yeah. You got it. All right, good job, guys. All right, you ready? Okay, so like I said before, the prior learning, the stuff that you've learned already, we're going to go over just really quick. And as we go through it, you are going to fill in the blanks of your notes. So where you see a blank in your notes, you're going to write the answer. Does that make sense? Cameron? Yes? Just nod. Just nod. Just say yep. Mm-hmm. Okay. All matter is made up of atoms. You could say particles, because that's probably the word that you used in 5th grade, particles. But now we know it's actually atoms. Right, Jess? Yeah, just nod. These particles can move at different speeds when what is added or removed. So these particles, they move, right? So what makes them move? You know this. Heat. There we go. The more thermal energy, aka heat, that is added, the what?
More.
Faster or more. Good. So the more heat I add, the faster those particles are going to move. When heat is lost, the particles move slower. When they move so slow that they're in a rigid format and they're just vibrating in place, we call that a solid. When the particles can slide past each other, we call that a liquid. And then the particles have no shape and they zoom around, we call that a gas. It may look like this. You may have seen pictures like this, right? So you've got solid, you got liquid, you got gas. The solid, look, the particles, or the atoms, or the molecules, are all in a shape, a defined shape. It has a volume. The liquid, it's moving around, and the gas is just kind of all over the place. We've seen this before, yes? Just nod. Mm-hmm. Okay. So I'm going to take you a little bit further. So you know that because they're moving, that has something to do with it. But what actually holds the solid in place? Because they're still vibrating, right? They're still moving. What's holding it there in place? What do you think?
Their temperature?
Temperature, maybe? What do you think? Maybe. Now, let's expand on that a little bit. If it's a chemical bond, like chemically, you would have a new substance. If I have an ice cube and then it melts, it's still water, right? So it's not a chemical bond, but that's good. I like your thinking. Yep.
Electrical charge.
Electrical charge. Maybe. That might have something to do with it. Jess, what do you think? Is that your thinking face? Yeah. I like it. Anybody over here? So she said there's something about the charge. Something about the charge. What do you know about positive and negative charges? Like, where have you, when you were in 5th grade, you probably played with these things. What? And they like pull magnets. They have a magnet. Magnetons? I would like to see one of those. I don't know what that is. Do you? Okay. So maybe there's some sort of magnetic field. Ooh. Ooh. What do we call, and you guys know this, you do. What do you call something that either pushes or pulls? A force. You guys knew this already. You just gave me the chills. You know that? That's awesome. Okay. Whoops. It's a force. That's what holds it together. Specifically, it's called an intermolecular force. Okay, so you know they move. That has something to do with the change in state. But what keeps a solid is that force. Okay? Are you writing this down, babe?
Yes.
Yes, just nod. So, as you go through your notes now, whatever is underlined up here in the PowerPoint, that is what you're filling in your notes. So, intermolecular force. This is the attractive force that exists between the particles of a substance. Okay? This is what keeps a solid, a liquid, and a gas is not affected by this force because the particles are so far apart that there's no attractive forces holding them in place. So remember that any force, by definition, is a push or a pull, which you guys nailed. Awesome. And so the particles themselves are attracted to each other. All right, which we kind of already touched on this, but I want you to talk with your people at your group. And I want you to come up with like a summary, like how do I put all this in words? Discuss with your group, what do you already know about the atom that would cause this attractive force between the particles? We already touched on it. So I want you to talk about it, and I want you to write me a statement on your notes. Number 2, part C. While you eat some nerds.
When it hits the ground, it's either positive or negative. So if it's positive,
Bro.
It's not asking what kind of.
So what do you already know about the atoms that's going to cause some sort of attractive force?
Not what atom is it?
All of them. You know this. You know this. What you got?
I feel bad now. He said I made him feel dumb.
She sounds so smart.
Y'all are all smart. What'd you come up with? What are you going to write down?
So, it's like lightning. There's a negative or a positive charge in the clouds, and there's a negative or positive. So if it's negative in the clouds and positive on the ground, the lightning hits that spot.
That is
because positive
You're right. I feel like she's
negatives
smarter than me right now.
are attracted to each other. That's why the electrons stay in the electron cloud, because the protons in the nucleus are pulling it closer.
Give me more than one.
Baby
More than
gravity.
one. More than one. Can you say that out loud? Can y'all just listen to Savannah real quick? Can you just explain? Let her just explain to you what she just said to me about this. Go ahead. Go ahead.
So it's kind of like lightning. There's either a positive or negative charge in the clouds, and there's a positive or negative charge on the ground. If it's negative in the clouds, it's positive on the ground, and that's where the lightning hits. So the negative and positive are attracted to each other.
I needed y'all to
That's
hear
why
it.
The electron cloud, the electrons stay because the protons in the nucleus attract it. It's like baby gravity.
That's right. Y'all needed to hear that. Y'all needed to hear that. Well done. Well done. Right?
Yes, Savannah.
Okay. So finish up with your groups real quick.
I didn't even know that.
With that maybe new information. What you guys write?
I probably forget it.
They're all magnetically attracted to each other.
Because why?
Because you're
What about the atom?
They're negative.
There we go. Because the charges of the
Atoms.
subatomic. Yeah. You got it. See? I knew you knew it. All right. So, what do you already know about the atom that would cause this attractive force between the particles? Somebody share with me. Raise your hand. Share with me. So, what do you already know about the atom that's going to cause this attractive force?
The charges that it has,
The charges that what has?
the protons and the electrons.
The protons and the electrons. So because those subatomic particles have those charges, it's going to cause this attractive force, right? Awesome. So make sure you kind of write that down. You got it! All right. So this is the next part. Again, you're filling in where I've underlined up here just to kind of summarize what we just learned. So particles have an overall... All right, get these. If you're finished, go ahead and grab the graphic organizer. That's how I'll know we can move on. Perfect. And at the top, there's critical vocabulary. And based on what we just went over, you can kind of start that. I want you to put it in your own words. So the critical vocabulary here is kinetic energy, phases of matter, intermolecular force, and then particle charge. So what does that mean to you? Put it in your own words. I think we are good. All right.